All right, hi. Good morning, everyone. My name is Eileen. I'm the Director for Student Life. Welcome to our School of Material Science and Engineering talk. I'm sure all of you here are curious about what materials engineers actually do and how material science can be relevant to you. So today I'm going to give you a brief introduction of what our school is and obviously how materials engineering is going to be relevant to your future. Now, I'm sure if you are thinking about what to do as part of your career considerations, you may be wondering what kind of jobs are available out there. Now, of course, we are now living in a very high-tech, right, AI-powered future. So obviously, these are some examples of emerging technologies, as we know of now, that would perhaps contribute to jobs waiting for you by the time you graduate. And as you can see, these are some examples of technologies which are already developing, and I'm sure in the next 2 to 5 years from now would already be established enough such that they will require engineers to actually work on these technologies. So if you can look here, you have things like electronics, you have healthcare, you have robotics, of course. Just as the robot that actually cleans my floor, you probably would see a lot more robots roaming around us, and we have already kind of gotten used to that. But definitely a lot more developments required, definitely in terms of materials innovation. Likewise, there's a huge call for sustainability, clean energy, right? As well as, of course, batteries that powers all our autonomous vehicles, our robots, even our cell phones, right? That we are so used to carrying around. Now, I'm sure you appreciate the different emerging technologies that are out there, given by these examples. But what is really the most important commonalities between all these different technologies is that they all require materials. Now, there won't be any industry or application that do not require materials, and in fact, in order for any technology to be able to advance and have a breakthrough, what typically is required is a materials breakthrough as well. And that is really what's happening at School of Material Science and Engineering at NTU. And I gave a few examples of some of these innovations that are happening that are leading the future. And you can see different professors from NTU MSE working across various areas of materials applications, ranging from electronics that are wearable now. So this invention by Professor Li Puisi actually uses your perspiration or sweat to actually power the batteries so that as you are jogging, clocking your steps, right, your 10,000 steps, you are also able to charge your phones or your Apple Watches and things like that. And I think these kinds of technologies, once they are matured enough, will definitely be readily available in our daily lives. Now, likewise, as you guys may still recall, the pandemic, right, the COVID, where we all have to, work with materials and materials used for mask coverings and things like that. And as the technologies develop, should we do need to encounter another pandemic, we will hopefully be much ready for that. And again, you can make use of nanomaterials infused with biomaterials as well to actually create high-tech mask materials that can better protect us from diseases and hopefully the next variation of the COVID virus, if any. Well, other than healthcare, we also have quantum computing. And I think all of you have followed the news on AI. And I think quantum computers are going to be the big next thing. And I do see maybe in the next 5 years or 10 years or so, each of us could perhaps be walking around with a quantum computer in our pockets, just as our smartphones. But in order for that, to be shrunk to that size in terms of the palm-sized device, we do need the materials to catch up as well. And that is what Professor Liu Zheng from our school is actually developing. Very, very small, two-dimensional materials that are lightweight and yet highly functional and powerful so that they can actually achieve the desired computing capabilities without having to expand the device size. So the dream to actually own a palm-sized quantum computer in our hands, right, would actually be possible with the materials innovation that is up and coming. Now, we also do know about semiconductors. All of you following the AI trend would know that semiconductors, the chips, are essentially the center of what is helping or boosting the entire advancement of robotics, ChatGPT, and all these different high-tech technologies, right? And so at the core of these things, the semiconductor chip and the materials used in the chips are very, very important for the advancement of these technologies. So we have Professor Nirpan as well, working on various facets of semiconductor materials, whether or not it is getting them to be highly functional, greater efficiency at doing what it's supposed to be doing. You can also get them to adapt to stimuli such as light, temperature, pH, and things like that. And color changing semiconductors, if you think that that is quite a crazy idea, it is not, because you can totally imagine applications that will require that. For example, windows that would tint or change the tint color according to the temperature, or clothing that responds to different stimuli, right, as the needs for advertising and so on. So again, I think the applications are endless, but what we need to focus in is that materials innovation is definitely crucial to these developments. So of course, you can also talk about sustainability, whether or not it is recycling your old PCB board for something healthcare or cell culture related, or to ensure that our batteries that we do throw out in our electronic devices are actually getting recycled and converted to something useful. So all of these concepts on sustainability, clean energy, robotics, healthcare, right, nanomaterials, AI, all of which is what NTU MSE professors and our students are working towards. And so if you do like what you see, then definitely you can imagine when materials are needed everywhere, regardless of whether is it in aviation, automobile, urban cities, sustainability, or even places like oil and gas, right? Electronics, manufacturing, biotech, healthcare, you will be able to find jobs for materials engineers, regardless of what sector that you want to go into. And so if there's a particular logo, a company logo that you are looking at, and that is something that you wish or aspire to get into, then materials engineering will be a good place to start doing that. So I hope I've shared with you what material science and engineering is about, and hopefully you are excited about the possibilities that a degree in materials engineering can actually bring you, and of course the widespread, diverse career options that are related or available for MSE graduates. Then I guess the next burning question is, why do you want to come to NTU and not any other universities out there? So I think the first important question that you want to ask yourself is, what do you want to gain out of a university degree? Now, surely investing 4 years of your time, money, right, your youth, you want to get a good degree. Not just good, but also world-class good. And material science and engineering in NTU is one of the best materials engineering institutes in the world. And I liken this ranking to what you would call, reviews, right, when you are looking at what to buy on Shopee or Lazada. And the reviews are essentially given by existing users. So the analogous to us in terms of ranking is that the students will rate the school. The employers who hire our students will rate the school. Fellow academics, fellow scientists, working in the universities will rate the school. And collectively, these ratings are actually collated, and you would get some kind of a score that allows you to compare from A university and B university. So that essentially is the essence of ranking and how you should use it to actually help make your decisions in choosing the correct university. So I'm happy to say in the recent 2025 QS ranking, which is the latest one, material science and engineering is actually ranked number 2 in the world. So this means that comparing across all our friendly neighbors from MIT, Stanford, Berkeley, NUS, right, Cambridge, Oxford, Tsinghua, Beida, and all these good universities, NTU MSE is actually one of the top, second best. All right, we're happy to lose to MIT, that I'll take, but what you'll be assured in coming to NTU MSE is that you'll be getting a world-class education. And you don't have to pay very much and go very far, so that's really the good news. Now, of course, what is associated with ranking are the faculty, meaning the professors that actually do teach you, offer you projects. So here I have the top 2% scientists in 2024, where they rank, this is done by Stanford University, by the way, where they actually rank all the scientists in the world, and regardless of what expertise, so long as they are top 2% in their field, they would appear up here. And if you can do a quick calculation in terms of number of heads that you can count here, we have about close to 20 over faculty members. And material science and engineering has about close to about 45, 50 faculty. So half of our faculty are actually on this list. Now, what this means for you is these professors will be teaching you courses. They will be teaching you their expertise. They will be guiding you in projects, whether is it the final year projects or research projects or ad hoc projects that you take with them. And you can partner them in collaborating to help develop all those cool materials innovations that I've mentioned before to help lead the way in advancing the technologies. So that's really the upside of ranking. And of course, with a well-recognized degree, wherever that you choose to go to work, whether in Singapore, in China, in US or Europe, this is the degree that they will recognize because this is the institute that is actually world #2. Now, in terms of curriculum, we also do prepare our graduates, and we want to ensure that every single one that walks out our door is fully well-equipped for the industry and fully well-prepared for whatever careers that may await them. So we adopt a very humanistic, experiential approach when it comes to teaching, where we allow students to learn while they experience, and they do things, right, through interaction with, experts and amongst themselves as well. And we also take very serious consideration in terms of infusing industry into our curriculum. So we want our graduates to come in here to be trained, to learn the theories about all the different materials knowledge, but at the same time already know how to work with industries, how to work with practicing engineers to deliver solutions to real-world problems. And of course, we offer quite a number of degree programs at NTU MSE, and these are the 3 different types of degree programs: a single degree in materials engineering. There can also be a double degree in materials engineering and economics, as well as a second major in something. So to give you guys an idea so that it's not so confusing, I'm going to use an analogy that hopefully you understand very well by just looking at that. And that if you come into NTU MSE and take on a degree, it is analogous to ordering a meal at McDonald's, for example, where you have a burger, a drink, and a fries. So the burger will be like your core subjects that you need to take related to materials engineering. The drink would be courses that you take that is not related to materials engineering in sort of a broadening sense. And of course, you can also go very deeply into subjects related to material science, and that would be called your electives and so on. So if you do complete the entire meal, usually in 4 years, you will be awarded a single degree, and that will be a Bachelor of Engineering in Materials Engineering. All right? And of course, for those of you who are coming with relevant diplomas, can expect to graduate a little bit earlier through subject exemptions. But again, the choice is up to you, how fast or how slow you want to graduate. Now, if you're not so satisfied with a single degree, and then you want to do a bit more, so you can also go for a double degree. So this means that you're actually doing 2 degrees. But in order for you to do the 2 degrees, you will actually need a lot more time. So this is analogous to digesting 2 set meals. 1 meal for materials engineering and another meal for economics. So instead of a 4+4 where you need 8 years, we can shave off some time and double count for certain things. So, but still you need to spend 5 years. And at the end of 5 years, you will be conferred 2 degrees, one in materials engineering and the other in economics. Now, I think a lot of you may not want to go into that option, but you are also not so satisfied with just doing a single degree. Then maybe you can consider what we call a single degree with a second major. So that is analogous to ordering the same set meal, as I've mentioned before, for a single degree, but then you also order a side. So whether it's your chicken nuggets or your cheese fries or some waffles, whatever. So this second major will be on top and beyond what you are doing for a single degree. And that can only take 4 years and no shorter due to the rigor of this program. All right, so I hope this gives you a good idea of how much rigor, or rather how much time you need to spend doing what you need to do in the university should you choose to take any of these 3 options. So what are the different flavors of sites that we offer? Meaning, what different types of second major programs can I choose from? So as of now, we have a total of 7 different ones that you can choose. So I have them up here. So we can either be in business or data analytics, sustainability, medical biology, pharmaceutical engineering. You have also a new one, which is actually future foods. So again, you have to make that decision during the admission to indicate which choice of second major that you will want. But again, don't worry, once you do come into NTU MSE, we can still allow you to switch. All right, so don't need to really fret about what choices. And again, we are always, just an email away, or do come visit us in one of our physical events. You can always clarify, how best to make your decisions. So we allow you to build expertise at NTU MSE, and I think that is very important because a lot of you may think that materials engineering is very broad. Chances are you may not be good at something. You want to build a certain expertise so that you can market yourself to future employers, that you're an expert, in materials and AI, or I'm an expert in materials related to healthcare. And we do allow you to do that. And the way that we have created or designed the curriculum is such that in the first 2 years, we give you broad training, allow you to be exposed to all sorts of fundamentals related to material properties, materials behavior, and so on. And this is not just the theoretical skill sets. We also train you to have some technical expertise in order for you to be able to, operate certain equipment and analyze the data related to those. So this is for all students coming into MSE, and in the first 2 years, we think of it as a very broad-based, very versatile sort of a training. But in the third, fourth year, that is where you can choose to develop certain expertise if you want to, meaning by taking certain subjects according to your interests. You can also go for one out of the 7 different specializations that I've listed up here. So suppose to say you're very keen on going into a career that is related to healthcare. So you may want to take subjects related or falling under the basket of the specialization, for example, in medical materials. So once you complete those courses, the specialization will be reflected on your transcript. So then you can go to an employer and say, hey, I have training in all sorts of materials, but I do have an expertise in medical materials, which is relevant to me helping you develop your medical device, right, in your company, and so on. So again, curriculum aside, we also pride ourselves in ensuring that our students are exposed to the industry beyond the classroom. And this can take place in the form of things like company visits, right? Workshops that we curate for our students. We also do have a third-year capstone course where we deliberately partner with industries where the students work in teams to actually solve problems that is specific to the companies. So it's again a very authentic learning experience where they work with engineers to actually produce solutions which can be adapted to the company's operations or needs. So very real, realistic, authentic learning, and we are all to expose our students and to allow them to gain as much industry experience as possible so that by the time they actually graduate, they would have quite a number of industry-related experience that they can list on their CV, and they can hopefully help make them more competitive, right, to their fellow applicants for the same job. So again, the industry engagement and immersion comes not in the form of a classroom or a guest lecture, but we do go beyond and above that to actually give our students the experiential interactions and, of course, real contacts with alumni coming in from various industries to really share their experiences to our students as well. So other than the academics, we also give our students a lot of platform, opportunities, and support to help them in whatever pursuit in their interests outside of the coursework and a curriculum. So whether or not they are interested in research, they can participate and receive funding for things like conferences. They can also go overseas for experiential trips. Likewise, if those of you who are very into innovation and you want to start your own company, there are also many different competitions and platforms and workshops that you can go to, to hone your entrepreneurship skills, or even produce prototypes in our MSE Makers Lab, right? With all the equipment and materials that are ready for you. NTU MSE is really here to support and to help develop our students to their full potential. So, in my ending slide, I hope you guys will consider NTU MSE. I hope all of the things that I've told you today about School of Material Science and Engineering has somewhat got you excited about thinking or considering NTU MSE as one potential choice. I do hope that you will have a chance to visit us at the open house on the 28th of February this year, 2026, to meet us in person, to come ask your questions, to join our lab tours, and perhaps also interact with our faculty or our existing students to find out more about what is it really like to be part of the NTU MSE family. So if you are looking to, build a degree, have a degree that is world-class, gives you endless career options, to be able to build an expertise that aligns with your career aspirations, or even just look for ways to develop yourself to the fullest potential and to pursue whatever interest that you may have, whether it's innovation, entrepreneurship, or even be an eco-champion, for example. NTU MSE is here to support your journey. And of course, lastly, as I've always mentioned, materials are really the most important building block of any industry. And if you want to see a certain technology gain a breakthrough, then materials is really the place to go. So if you do have a burning desire to want to change healthcare or sustainability, clean energy, or to build the next generation, EVs for Tesla, for example, then do join NTU MSE, because that is where you can make an impact to the world. So with that, I've come to the end of my talk. Again, this time only allows me to share with you some highlights of the school. But if you do want more information, please scan the QR code or do come to visit our socials and school website to really find out more information about the curriculum, as well as how to apply, admission deadlines, and so on. So with that, thank you very much for your time, and I hope to see you at NTU MSE.